Hello and welcome to our weekly science challenge video. I'm going to take you back over the last few weeks' challenges that have all been run on Show My Homework and through email, and then I'm going to set you a new challenge for this week. So this was the challenge in week 1. You may or may not have seen this. If you haven't seen this, this is a propagator. I sowed some seeds inside, but I wrote on the outside see-through plastic casing the name of the seeds that were underneath, so courgettes, rocket, and so on. Watered the seeds and then left them on a windowsill. I came back later, but I noticed that there was no condensation forming underneath and around the letters. So that was the challenge. If you didn't take part now, have a think about what the answer might be. So a little bit later on, when everything cooled down, you can see that actually there was some condensation underneath. Lots of people sent me some answers saying that the permanent ink, the chemical must have soaked through, and then actually some people sent me what they think is the right answer, and actually that the black pen, when the heat from the sun was on it, actually that was radiating heat outwards throughout the plastic, and it was stopping condensation from forming underneath, because actually the plastic underneath was just too warm for the water vapor to turn back into a liquid. Challenge 2, this is a good one. I was standing in a brook whilst out on my daily exercise, and I was stood still, but you can see, if you look closely, even though I was stood still with the current flowing from left to right, there were standing waves, there were ripples in the water that weren't moving at all. And my question was, what's causing them? What are they and what is causing them? And I'm a chemist, so we need a physicist to explain to us what is going on.
So why are there wave patterns around Mr. Wallace's feet, and why don't they move? Well, to answer that, first of all, we need to look at what happens when there's more than one wave in one place. Because part of what's going on is that waves are coming down the water, they're reflecting off Mr. Wallace's feet, and then they're interacting with each other. So when there's more than one wave in one place, the waves add together. So on the left-hand side, you can see that the two waves that are there have added together to make a bigger wave. We call that constructive interference. On the right-hand side, you can see that the two waves, one is positive whenever the other is negative, so they cancel out and we get no wave. Now, what does that look like then when we have more than one wave moving in opposite directions? Well, I'm going to show you an animation here. So we've got the red wave and the blue wave travelling in opposite directions, and when they add together they make this black wave. We call it a standing wave, and you can see that it gets bigger and smaller, but there are points like this one here where the amplitude, how much the wave goes up and down, is very large. We call that an antinode, and there are places like this place here where the two waves always cancel out and we get nothing at all, and we call that a node. An example of where we see this is on a guitar. So if you pluck the string on a guitar, then the waves travel out from where you pluck it and they reflect off the end and come back again, so that the two waves interact. Now, if you slow down the effect of that, what you see is something like this. So you can see there the wave patterns. We've got stationary waves forming with those nodes and antinodes like we saw before. So coming back to Mr. Wallace's feet then, there are waves travelling in from the left-hand side. They reflect off of Mr. Wallace's feet and go back the other way, and where those two waves interact we get this stationary wave pattern in the middle, which is why you can see the ripples there.
And there you go. Incredible. Thank you very much, Mr. Benjamin. Wonderful. So that was the challenge and the answer of the second weekly challenge. So challenge number 3, the tulips in my back garden. Why is it that the height of the tulips decreases as we go from left to right? No other information I don't think I gave. Everything was the same in terms of soil conditions, how they're watered and fed. The left-hand side of my shed is the west, and the right-hand side of my shed is the east. That was the only clue. So, as you can see, other than the fact I have a delightful back garden, but the sun, as it was rising and as it was coming up over the fence on the right-hand side, the early morning sun hits the tulips on the left and then moves across towards the tulips on the right. So actually the soil is going to be warmer on the left-hand side, so maybe that had to do with the way in which the bulb grew, but also the way in which the plant then grew upwards and got taller, because there's more sunshine on the left-hand side than on the right-hand side. Challenge number 4. This was a great one. So many people got involved in this and really went for it. So can you find and photograph elements from your house? Can you find any pure elements or elements that are mixed in with other things or in compounds? Take a photo of the item and take a photo of the item next to the symbol on the periodic table. And I'm going to be making up a big periodic table of all of these photos. Here's some examples. If you still want to do this, I'm still looking for lots more elements on the periodic table. So this is something that could be ongoing over time. Here we are. We've got some great examples from one of my Year 11 students. We've got chromium and nickel in coins and keys, iodine in milk, and sulfur in eggs, all sorts of examples of aluminium and silver, tin in tins, and fluorine in the form of fluoride ions in toothpaste as well. And then another one of my Year 11s produced these photos. We've got lithium in the battery of laptops. We've got potassium in fruit. We've got argon, a gas in bulbs, and tungsten, the filament in bulbs. Aluminium foil, beryllium in springs, sodium in salt, mercury in a thermometer, and and phosphorus in matches as well. Brilliant examples of elements that you can find in your home. So, week 5's challenge. I will refer to myself and I will introduce this challenge. Right, new challenge for this week, and this one is mildly tricky. What you need is some form of sticky label, post-it note, something. Other brands are available, and you need a very dark room / cupboard, but something that you can fit into. Bear with me. And what you need to do in that very dark, completely pitch black room is you need to look very carefully at your post-it note as you peel it off, and hopefully you will observe something, and then you need to find out what it is and why it is doing it. Enjoy your darkened cupboards. Thanks, me. Right, moving on, and a bit of an we, as a science department, have got a few ways of putting things out there. We've got a Twitter account, the @Myton Science Twitter account at the moment. There's all sorts of suggestions and bits and bobs on there. We have this YouTube channel. As the subscribers hasn't quite hit the required number at the moment, the channel URL is a bit messy. It's kind of youtube.com/blah. So I've made a tiny URL just here that makes it slightly easier to follow. And then I'm going to start putting up videos of Flashbang Friday, which is something that takes place in one of the labs in science every Friday. Obviously, it's not taking place at the moment, but lots of the videos from the past are on an Instagram account from one of our students who said that we can have a look. So flash_bang_Friday for lots of those, and some more will be appearing on this channel soon as well. That's it for now. Bye-bye.